Have you ever felt like the quantum world defies all common sense, making you wonder if our brains are just not wired to grasp its fundamental truths? Making sense of quantum theory means embracing its deeply counterintuitive nature, focusing on its incredibly precise mathematical framework, and exploring the various philosophical interpretations that attempt to bridge the gap between abstract equations and our perceived reality. The challenge stems from quantum mechanics describing reality in terms profoundly different from our everyday experience. Concepts like superposition, where a particle can exist in multiple states simultaneously, and entanglement, where particles remain connected regardless of distance, defy classical logic. The act of measurement itself plays a unique and often debated role, influencing the system's state, leading to what is famously known as the measurement problem. These are not merely complex ideas, but fundamental descriptions of how the universe operates at its smallest scales, which is why our classical intuition often fails us. To truly begin making sense of it, you should first focus on the predictive power of the mathematics. The equations of quantum mechanics provide extraordinarily accurate predictions for experimental outcomes, regardless of how strange the underlying reality may seem. Next, delve into the major quantum interpretations, such as the Copenhagen interpretation, the many worlds interpretation, or objective collapse theories. These interpretations offer different conceptual frameworks for understanding what the mathematics describes, but none is universally accepted as the definitive truth. Recognize that quantum mechanics requires a shift away from classical determinism and into a world of probabilities and inherent uncertainties. One insider perspective is understanding that quantum mechanics is often described as a "shut up and calculate" field, a phrase attributed to physicist David Mermin. This highlights the scientific community's long-standing reliance on the theory's predictive success, even while philosophical debates about its meaning continue. Exploring these interpretations is not about finding the right one, but about appreciating the profound questions quantum theory poses about reality, knowledge, and observation itself. Ultimately, grasping quantum theory is less about finding a single, easy explanation that fits classical intuition, and more about developing a new way of thinking. It means accepting that reality at its most fundamental level operates on principles alien to our macroscopic world, and finding profound insight in the elegant, if abstract, mathematical structures that accurately describe it.
If quantum tech fascinates you, like, subscribe, and keep exploring with us.